Well, Chatelier's principle states that if we have a system at equilibrium, like this one, which is represented in this diagram here, and we make some kind of change to that system, then our equilibrium will shift in order to relieve that change. So if we increase the pressure on a system like this in equilibrium, the system will shift to reduce that pressure. It's going to do the opposite of what we apply to it. If we were to decrease the pressure on this system, it would shift to try and increase the pressure again. So it's going to try and get back to that state of equilibrium. So in this reaction, how would that shift it? Let's look at this. If we increase the pressure, so if pressure increases, how would we know which direction this is going to shift? Well, the pressure is going to be based on how many moles are going to be in a volume. Remember the ideal gas law. It's PV equals nRT. If we increase the pressure, well, in order to achieve equilibrium, in order to avoid any of this stuff having to change, we would reduce our volume. And so this 2NO2, there's going to be a higher number of moles of objects on the left side of the reaction. And so if we increase the pressure, we're going to be shifting to the right. We're going to shift towards the side of the reaction that has a fewer number of moles. Likewise, if we decreased the pressure, in order to compensate that, we'd try and fill that volume with more gas, which we would do that by shifting to the left. Right? Because if I'm saying, hey, my pressure here increased and I want to relieve that pressure, how can I make some room here? Well, I can turn two of these NO2s into an N2O4. And so if I, between these two boxes, increase my pressure, so pressure goes up, then I'm just going to make an extra N2O4. And now I only have 3 NO2s. And so now it's a little more room. There's a little more space here to work with. So that's what that's going to look like. But it's not just going to be pressure changes. What about temperature changes? Well, if we increase the temperature, how is this reaction going to react? How is this equilibrium going to shift? This reaction is endothermic. And what that means is when this reaction proceeds to the right, it is going to absorb heat. So we could consider the heat to be another reactant on the left side. And so when we do that, then we can see if I increase my temperature, I'm increasing the heat. The heat goes up, and to relieve that, the reaction is going to have to shift to the right. If my temperature went down, my reaction would have to shift to the left in order to relieve that, in order to produce more heat. So then if I increase the concentration of either of these, if I shift my concentration, so let's just say, let's bring this down a little bit, let's just say the concentration of NO2 goes up. How's that going to shift my reaction? My reaction is going to shift away from that increase. If my concentration of NO2 had gone down instead, my reaction would shift towards the decrease in order to compensate for that. So it's always going to do the opposite in order to compensate for whatever change occurred. So now let's look at what this looks like in a graph. Here I've got my NO2 graphed in blue and my N2O4 graphed in green. So what that looks like is when this reaction first started, I had a high concentration of NO2 and I didn't have any N2O4. And at first, the reaction went very quickly, right? This curving almost straight down right off the bat. But as my NO2 decreased, my N2O4 increased, and so our reaction leveled off. And at this point, we are at equilibrium. So we would have a value of K here. Value for K. And so what would happen if I made a change? Let's just say I increase my NO2. What would that look like? If I increased the concentration of NO2, then my graph would suddenly have NO2 spike up. And then what's going to happen? Well, what's going to happen is it's going to look just like it did at the start. And I'm going to suddenly shift down until I level off. And my N2O4 is going to have a shift up and then level off. So once again, I will have hit equilibrium. But now what happens if I shift my temperature? Well, if I shift my temperature, let's say I shift my temperature down. Let's say I shift it down. Well, when I shift my temperature down, what's going to happen? Is this reaction, am I going to suddenly get a change in my products or reactants? No, it's going to have to happen gradually. So if I make a shift in my temperature down, then my reaction is going to want to shift to the left. And so that means I'm going to start to produce more of my reactants. And so I'm going to shift back up in my reactants. Then my products are going to shift back down. What would a pressure change have looked like? Well, a pressure change is going to look very similar. If at this point I had a pressure change, let's say a pressure increase, I'm going to have a steady increase of my products because a pressure increase caused me to shift to the right. Remember that? Then my products or my reactants are going to shift down again. So this is at each change here. Let's mark these changes. So at this change, I had an increase in NO2. At this point, I had a increased, what do we say, a decrease in temperature. And at this point, I had an increase in pressure.